Okay, so you you will have the midterm exam on Friday. Okay, so I will for this class. I know if you're in my other class, so you have a midterm on Wednesday, and then this class midterm on Friday, and it's going to be at home or wherever you want to be, really. 3 o'clock. Try to find somewhere quiet, and it'll go from 3 to 5. Now, I had a request from a student that they have a class that goes from 2 to 3, and then in order to get to like a quiet environment, they might not get to a quiet environment to like 3:10. So I can like shift the whole thing from like 3:10 to like 5:10. Would that create conflicts for anybody, or would that be like better? Does it not really matter? Shifting things 10 minutes? Is that okay? All right, so just for so we'll go ahead and do that. So it'll go like 3:10 to like 5:10 or something, and you'll just do it on the computer. You'll download the file. You'll put stuff in. I'll probably by Wednesday I'll post information about the data. Okay, so by Wednesday you can expect information about the data. So and kind of like a blank starter notebook will be posted, and then on Friday for the actual midterm, I'll post kind of the questions that will ask you to process the data and answer the questions. Right, make a few tables and charts. Did anyone attempt and work through kind of the midterm questions that were from last year? Did we try that? No? Okay. You really like if you didn't do it over the weekend, and I know you have to like study for other classes and stuff, but really like spend half an hour to an hour tonight working on stuff, and just like try to answer like a question, okay? And this will start to highlight like, oh man, I know how to do this, but I don't know how to do this, right? And anytime you have to look something up on Google, right? So you're probably gonna go online and like the first question, and you'll be like, maybe you know how to do it, maybe you get stuck on like, how do I group by, how do I aggregate, how do I do this? Write down the name of the function that you had to kind of search, okay? And at least on this piece of paper, and the whole thing's open note, open internet, just not talking to your friends. That's the only thing that's forbidden, is talking to other people. Write down kind of these functions so that when it comes to the midterm and actually having to do stuff, like maybe you won't remember the full syntax and exactly like what goes where and everything, but at least you can save a lot of time by knowing exactly what function name to search for and the documentation there. And if you've practiced or tried it a little bit, as far as the practice or last year's midterm, and I also posted homework 3. At least there will be some familiarity. Okay, it's that's going to be the large limiting thing. So I've posted homework 3. This will be due next week. Okay, I think I made it due a week from today, but I'll just double check. But I'm pretty sure that's what I did. Yeah, so a week from today. But I think just kind of working through and practicing with it will be helpful. And then I plan on releasing the answers to last year's midterm, I don't know, maybe Tuesday or Wednesday or something. But again, the plan is for you to kind of practice and figure out like what you know and what you don't know. Write down these things that you've had to look up and stuff. And a lot of these things, there's multiple ways to do stuff. Not to say that the way I did it was the best or the only way. But and I'll post my answers so you can kind of at least see one way to do it. Okay, and that should be there. Okay, I think by now I've met with every single group regarding the data for the final projects. And I look forward to the projects and stuff. And between now and 10th week, feel free to come visit me during office hours with questions, or to just kind of bounce some ideas regarding things that you're thinking of doing, and I'm happy to talk. And then and basically the final report is due whenever you've scheduled your final presentation. Okay, so you'll upload that on your GitHub, and then when you come to present, I'll open that up, I'll look at your presentation, and I'll read the report, and that will be that. Okay. Questions, I guess, about stuff? No? Okay. Okay, well, I think on Friday I wanted to start getting into stats models, but we ran out of time. And so today we'll look at stats models, and we'll look at kind of some intro Scikit-Learn stuff. This is just, I don't know, very, very shallow level stuff. So I think this week I'll just briefly touch on kind of some of these tools that exist for modeling data in Python. This stuff will not be put on the exam, but will be useful as far as your final project goes. And so I guess I'm trying to think how much time I want to spend on this, and then either 8th week or 9th week we'll talk about SQL, which is pretty easy to learn, in my opinion, and only needs a couple days of lecture to cover the basics of SQL. So, but we'll start here. And okay, so this is the package. We've talked about NumPy, we've talked about pandas, we've talked about matplotlib, and Seaborn being for visual exploration. And then we've also, and so today we're going to talk about stats models, and we'll see. I think I only want to say a few things about stats models, and really just kind of point you to the documentation for the rest, because this is not a regression course, and I'm assuming you learned regression already. Okay, and so so all of the tools and kind of stats models are largely regression based and things like that. And then there's Scikit-Learn. Okay, and so if you like, you can go online and search stats models versus Scikit-Learn and all of this stuff, and these packages are developed and designed with different approaches and mindsets. Stats models takes a traditional statistics approach. So when you learn regression in, I think, 101A, and you learned things like your coefficients and finding the kind of the standard errors of these coefficient estimates, and getting p-values for them, and to decide if they are significant or not, and you evaluate things like the AIC and the BIC to kind of decide whether or not to keep these things. That's what stats models does. Okay, and so let me go to the stats models website. So anyway, we'll import that, and there's statsmodels.api and statsmodels formula API, generally imported as SM and SMF. Okay, and then and I'll talk about Scikit-Learn, but Scikit-Learn doesn't take so much kind of it gets rid of a lot of the theoretical parts of statistics that you learned in like 101A and 101B, and focuses mostly on the predictive. You evaluate models with Scikit-Learn using kind of its predictive performance via cross-validation and something like that. Okay. Anyway, this is statsmodels.org, and this is what we've got. Okay. So here I'm going to just start with a very, very simple array. Okay, x is 1, 2, 3, 4, and y is 2, 6, 4, 8. And I'll go ahead and I'll plot this, and this is what it looks like. And we want to fit a linear regression model, right? So to make this plot, I did PLT scatter, and then I adjusted the x and y limits, and then I finally called show on it. Okay. All right, and then we can make a data frame with a dictionary of our arrays. Okay, and so this creates x and y. All right, and then so Seaborn does something very simple. Okay, and you can create Seaborn, the Seaborn plot, and it looks like this, and this is nice. Now the issue with Seaborn is it draws this regression line, but Seaborn will not tell you the coefficients of this regression thing. It's just kind of this visual thing. If we were to fit a linear model, what does it look like? It looks like this, and it doesn't tell us what the coefficients are. It doesn't allow us to really do any kind of analysis. That's not the purpose of Seaborn. It's frustrating because sometimes you want to get these bits of information out, but they've intentionally hidden them and made it difficult to extract this information in Seaborn, because that is not its intention. Okay. We would, but anyway, if we wanted to fit something like this with stats models, this is how we would go about doing it. Okay. So we've imported the stats models formula API as SMF. Okay. So this is how we interact with stats models formula API. Okay, and then there's a .ols, and the formula, this notation should look quite familiar. This is, y tilde x. This is often how we express our formulas in R, and data equals D. So this in of itself should not be a huge surprise. Okay, and you can see this is kind of their minimal example, and we're basically doing, I'm just following kind of the minimal example, but just on my super simple data set. Okay, and if you ask to print out the result of this thing, it's just going to tell you it's a linear model OLS object. Okay, so it's just doing ordinary least squares. Okay, now this is a little bit strange, okay, because in R, well, it feels strange now, okay, but once you start working with kind of the Python way of doing things, then maybe you'll get used to this. This just initializes the model, and it doesn't actually try to fit or estimate the coefficients until you call fit upon the model. Okay, so that you create one, and then you have to call fit onto this. Okay, in R, when you write something like this, you'd write like lm y tilde x, and it automatically will fit it for you. Okay, but here it just says it initializes the model, and then it goes and then it does the math. Okay, and this kind of separates the things in case you wanted to, I don't know, do something to the model prior to spending the computational time of estimating the things. Okay, and then so this is the model, and then after you fit it, I've stored this as results, and it tells me the thing here is that this is now a linear model up here. The model is a .ols, and then the results are now in a regression results wrapper object. Okay, and it gives me kind of the memory index there. Okay, now I can print the summary of the results, and this gives us like a big table of results. Okay, so it gives us the coefficients. The intercept is 1 and the slope is 1.6. It gives me the standard error, the t, all of this stuff. And I think it's very similar to the information that we would get if I did something similar to R. And so I know this is our Python class, but I'm going to go ahead and just do something very quick in R. So we'll do X is 1 through 4, and Y is 2, 6, 4, 8. And we'll do results is lm y tilde x. Yeah, I think that's fine. And then we'll do summary results, I think. So I got summary results, and what do? AOV results as well. Summary of AOV results. How do I get all of this stuff? Okay, well, maybe not. Okay. Well, anyway, so here's our intercept and our standard error and the t and the p values, and indeed those values match up exactly. I guess how do I do conf int on results dot coefficients? Okay, so the confidence interval for the results gives me this, and that's also included right here. Okay, and so we can see that those match as well. So these things match exactly what we get from R. Let me see, what else does R include? The multiple R squared and adjusted R squared appear 0.64, 0.46. The F statistic, which it shows up in the ANOVA table, is 3.556. So it basically contains all of the same information, just arranged a little bit differently. Oh, I guess there's our F statistic as well. Number of observations, degrees of freedom of the residuals, degrees of freedom of the model, and things like that. So all of these things. I am not sure what Durbin, Watson, or Jark-Barra is. I never bothered to learn. Do you guys know? Have you seen these? Durbin, Watson. Durbin-Watson test is a test for autocorrelation in the residuals. Oh, well, now I know. Okay. So autocorrelation, and it tells us that we'll always have a value. 2 means there's no autocorrelation, and something else means something else. Okay. Okay, well, I guess this could be something in the Jark-Barra. Okay, well, anyway, I think this presents a lot of results that we're kind of familiar with in R, except I think the R summary is a little bit more concise, maybe at the expense of not presenting everything that you want, whereas stats models, it goes ahead and gives you a whole bunch of information. Okay, and then with stats models, you can call stats models graphics and do A/B line plot. This sounds familiar, right? And then the argument is model results, and then here we plug in the results of our of fitting the model. Okay, so we do that, and then we'll go ahead and we'll make the scatter and plot this. And when we do that, it's what we would expect to see when we do fit the thing. Okay, you can if you want the ANOVA table itself, you can call ANOVA directly, and it will give you kind of the same exact results that we get from R. Okay, so those results match as well. Okay, and then if you want to make a prediction, you can provide it a dictionary of kind of each input variable. So in our case, there's only one input variable, but if you had an x1 and x2, you'd give it kind of a dictionary of the values for the input, and then it would plug it into the linear model or whatever it is that you are fitting. Okay, and so there are lots of examples here. Okay, so as far as stats models go, I just started off with linear regression, and kind of I always recommend just kind of looking at the examples of what they've done, and you can read kind of the reference documentation. And then, if you wanted to do things like logistic regression, you can fit a generalized linear model, so you do a kind of a binomial link function for logistic and things like that, right? So yeah, logistic regression, you have the binomial link function and things like that, and so that's what you have there, and these are all kinds of I don't know what you've kind of covered, but at least probably these things are familiar, right? Linear regression, generalized linear models, and ANOVA. And then, these other things also exist. But now we're also, man, I don't remember what the linear mixed effects model was. I remember vaguely, but I wouldn't know. I would have to read up on it, right? But, that's all of data analysis. There's no way you can remember every single model and when you're supposed to use every single one. But you say, well, you'll read up on it and see what's appropriate. Figure out what assumptions are being made and things like that. Okay, so all of this is available. So as far as a linear regression versus this is probably enough to cover quite a bit, right? And then you've got the technical documentation and the module reference, which covers basically a lot of things, right? So the OLS, and there's all sorts of documentation there. Okay, that's using the stats models formula API. The other option is to use the array notation, which is similar to how Scikit-learn does stuff. Okay, so when we do the formula notation, we do something like this. We do y tilde x, and this is something that we're kind of accustomed to seeing in R. Whereas a lot of other things in Python use kind of this array notation, okay? And so, here is my x, and what I'm going to do is I'm going to build an x matrix, okay? And the x matrix, if I want to fit a constant, is going to have a column of ones and along with my my x1 variable, right? And so this is basically what we're doing, and we're basically saying y hat is kind of our beta vector multiplied by our x matrix, okay? And so this is going to give us our vector of predictions, okay? And so we build our vector, our matrix x here, and then OLS, we don't really have to do much, and we already know the answer is going to be x transpose x inverse x transpose y, and that's something. But we often will call a fit command like this. So here the difference is that this is SM without the F, so we're not using the formula API. So back here, when I defined the model, it was SMF, okay, .ols, and here it is SM.ols, okay? And it's unfortunate, but the .ols is capitalized, and you just have to remember that. And I don't know. And if you forget, which is likely, you always just look up stats models OLS, right? And the internet will tell you it needs to be capitalized. Okay. So anyway, when you define the matrix like this, there's no longer a command of y tilde, which x variable, and it's going to just try to fit the entire x matrix here. Okay. And so if you have multiple linear regression where you've got multiple columns, that's all assumed to be in this X matrix, okay? And these are our, this is our response variable, okay, our outcome variable, and the input matrix X. We just initialize the model here. We do model.fit, and we store the results here. And then we ask for it to print the summary, okay? And the summary table, because I'm using the exact same information, is exactly the same as what I have back here, okay? So it's the exact same data. We're gonna get the exact same information, okay? Except here it was fit using kind of the NumPy array notation, all right? And you know, and if we wanted to, we could see that it was indeed just doing the linear algebra here, okay? So we could just do X transpose X inverse X transpose Y, okay? And this is what it looks like. The matrix multiplication, so you just have to get used to switching between R and Python and all of that. So X transpose, I think this is easier notation, is just X dot capital T. That's going to be X transpose rather than R's, you know, T parentheses X, but that's just me, all right? So X dot capital T will be the transpose. The @ sign is the matrix multiplication, so this is X transpose X. And then the inverse operation, you have to call NumPy linear algebra dot inverse, okay? And that's going to give us the inverse of a matrix. And then we multiply that by X transpose Y, okay? And then when you do that, you get 1, 1.6, which indeed is the coefficients that we're using for our very simple example, all right? Okay, and so this is just kind of your very, very, very basic intro to stats models. And as always, let me just include a link to the stats models website. And I'll just say be sure to visit and read the documentation on the stats models website. Okay, I don't know. Okay, so anyway, and it's just in this kind of table of contents area here. Okay, so we'll go ahead and we'll save that, and I'll restart and run everything and save and upload. I don't think I made huge changes, but okay. This NumPy array notation is often how Scikit-Learn processes things. So we'll go ahead and I'll just briefly intro Scikit-Learn today, and we only have a few minutes to kind of cover that. But we'll take a look, and then we'll spend some more time talking Scikit-Learn. Well, I guess here's the question. On Wednesday, should I keep talking Scikit-Learn, or should I go over like the practice midterm? And all right, okay, we'll do that. Okay, I can spend some time. I'll post the answers and stuff, but you guys can ask questions and things like that. I don't know how far. I only have 50 minutes, right, to kind of cover stuff, and it's a 2-hour exam, and I don't know. We'll see how far I get. Okay, but okay. Wednesday I'll do some stuff over the practice midterm. Again, please, you were supposed to do it over the weekend, but if you didn't, make sure you take a look at not the practice, but I guess last year's midterm, and then take a look at this week's homework as well, okay? And I think both of them are intended to kind of give you some exercises and pandas to kind of help you out, okay? So, all right, let's take a look at intro Scikit-Learn, and I guess we'll put this on hold until next week as well. So, we'll see what we talk about today, and then we'll look at some more examples next week. Okay, so Scikit-Learn. Scikit-Learn is a huge thing, okay? This is like probably one of the most popular modules in Python for kind of machine learning, but just fitting models, okay? You can fit ordinary least squares regression, and there's all sorts of stuff, okay? So you have these models like classification, okay? And then you have regression models and you have clustering models, okay? But there's also a ton of stuff on, there's a bunch of things on model selection, okay? And then there's a bunch of stuff on pre-processing, okay? So I guess, if you're in 102, like my 102B, we touch upon some of these things, right? We'll touch upon classification, and then we haven't gotten there yet, but we'll touch on clustering and we'll touch on dimensionality reduction. Some of these kind of just broad, big picture ideas. And for each of these things, there's like tons of different methods and models. And, as far as the intro 102B class goes, we'll only cover like a handful for each, or like dimension reduction, we'll only talk about one. But a lot of the stuff that, I think why people like Scikit-Learn is there's these big modules for pre-processing and model selection, okay? And so pre-processing is stuff like cleaning up your data and getting it into a form that's easy to work with, or allowing you to build new variables. Things like taking a categorical variable, which is often, a lot of our models require numeric inputs and stuff, and so it can take a categorical variable and it can turn them into dummy variables, right? You can turn everything into kind of like ones and zeros and things, these dummy variables out of categorical stuff. There's stuff on feature extraction. There's a whole bunch of these things, and you click any one of these these are like the big 6 categories of stuff for Scikit-Learn. You click one of these things and you look at these modules, and there's like a ton of stuff, right? There's standardization and mean removal and variance scaling, so things like scaling your data. There's nonlinear transformation, so you want to do things like take logs of your data or map your data to some kind of distribution. There's normalization, there's encoding categorical features, discretization, which is all about like taking a numeric variable and then turning it into categories, right? Like taking from you got numeric and you turn it into low, medium, high, or you do something else to turn, there's all sorts of stuff. Imputation of missing values, how do you fill in the missing values? And so these are all like kind of just broad categories of stuff, and the documentation is very, very, very long. Okay, there's a lot of different things you can do to your data, and they're very useful, and you can create these things called pipelines, and maybe we'll get to talk about that a little bit. I'm not sure, and I'm not expecting your projects to go super, super, super in depth, right? Like people will spend their entire careers, right? Senior data scientists will spend like months working on some kind of data pipeline thing to create a model, and you're going to just do a basic project that, in like 3 weeks or so. I think that's enough to get some interesting findings, but there's all sorts of stuff, right? For model selection, we have things like cross-validation, and this is really Scikit-Learn's method of choice for choosing a model. It doesn't do stuff like you know, in linear regression, you have the AIC and the likelihood ratio test, and I don't know what else you have for like deciding whether or not to include a variable. Okay, Scikit-learn just uses cross-validation. This is kind of its primary thing, and it says, well, this was your test data, and you split it into training, or not your test data. This is your training data, and you split that further into training and validation. And so we fit the model to the training, and this is how well it performed in the validation. And we did it, and it performed great on all validation sets. Therefore, it's got to be a good model, right? It's got to be a better model than this other thing that didn't perform as well. So that's kind of what it does. And so there's all sorts of things for cross-validation. My web page is stuck. So there's, I don't know, lots of stuff, right? K-fold, leave one out, and all sorts of stuff you didn't even know existed. I don't even know what this is. Cross-validation iterators for grouped data. Okay, something, right? Somebody found that useful and decided to code that in there. And then you have all sorts of things to kind of measure the performance, right? So you have, oftentimes we just look at something like the squared error loss, but there's all sorts of other ways to measure your loss function. And so Scikit-learn includes all of these things, okay? And then as far as the modeling goes, okay, maybe we'll just start with regression because it has our most familiar thing, ordinary least squares regression, which is great, okay? And then it includes like every version of regression that I think, I don't know about every version, but a lot, okay? And it's kind of just like, if somebody publishes a paper on like a new method of regression that is kind of like almost, as if that paper gains any kind of traction, somebody will implement it into Scikit-learn fairly quickly. So Scikit-learn is like constantly adding stuff and getting rid of stuff that people don't like, and it's constantly changing. So, you know, the basic things like ordinary least squares regression, that's not going to go away. Okay, I would be shocked, But okay, so now you know you got OLS, and then you have ridge regression and lasso and elastic net and multitask lasso. I don't even know what that is, right? So a lot of these things you're gonna like. So you know OLS. If you've taken 102B, you should probably know ridge and lasso, and then you know there's all of these other things that do stuff, right? And then you have all of these other things, you know, discriminant analysis and support vector machines and gradient descent and nearest neighbors and all sorts of stuff, right? Naive Bayes. All of these different kind of things that, you know, decision trees and, you know, so they exist, right? And no matter how you've specified these things, they all follow a similar notation in their use, okay? And the general notation looks like this, okay? From sklearn, okay, import one of these modules, right? So sklearn is this huge package. You probably don't want to import everything, okay? So you'll probably just import the things that you're going to use. So in our case, like if we're going to do linear regression, we'll probably import the linear model thing, and then you define your model here. You do the model that I want. I'm going to call regression, and this is going to be linear model.linear regression, okay? And then you call regression.fit. This is not a good example because they type in the data directly, okay? But I don't know. Well, if you look at this, their X you can see is a 3x2 array, okay? So regression.fit is 3x2 because we got 0, 0, 1, 1, 2, 2. And so you have x1 is 0 and x2 is 0, x1 is 1 and x2 is 1. This is a terrible This is like the predictors are linearly dependent, so that's not good. We're gonna have some issues there because there's no matrix inverse, but I guess it can handle that. Okay. And then over here is going to be the values that you're going to predict, the y. Okay, so I think I've got something kind of basic like this lined up as well. So here I've got NumPy, pandas, matplotlib, and so I'll start by doing from Scikitlearn import linear model. And here I'm just creating some random x and y values. So I just say do random 50, so this will give me random uniform. I multiply by 10, so now my values go from 0 to 10. And then I'm going to just, so the true model is has an intercept of 1, a slope of 0.8, and I just add some random noise to each of these things, and I get, this is my data, all right? And so y is a vector of output values, okay? And so here I will go ahead and do linear regression dot linear model, and I'm going to define fit intercept as true. Okay, if I can also do false and just make sure that my x is a matrix that includes a intercept column. Okay, if I ask for the model, it kind of just tells me what the model is. Right now there's no coefficients because it hasn't really been fit. This is what my x variable looks like, and so my x is just a vector, so we have to turn it into a matrix. Okay, Scikitlearn requires everything is a matrix, so I go ahead and do this, and so I've defined the model up here as linear model.linear regression. Okay, much like what we have here, except I gave it the option of fitting the intercept because my x matrix does not include an intercept, and then you just call model fit between your predictors x and the outputs y. Okay, and you go ahead and you do that, and then you can ask for the model coefficient, which is 0.827, and the intercept, which is 1. Okay, and that's that. Okay, and that basically fits the model. So this is the result of fitting Scikit-Learn's linear regression model, which makes sense. Okay, now Scikit-Learn, unlike stats models, is not going to give you that whole thing of p-values and ANOVA and things like that. That's not Scikit-Learn's philosophy on choosing a model. Okay, Scikit-Learn's philosophy is basically how well does it perform in cross-validation? How well does it do? So if you want the standard errors of your coefficients, and if you want the p-values and stuff, Scikit-Learn is not the package to use. Okay, it just allows you to kind of fit a thing, and it gives you this, and then basically later on you're going to evaluate the fit by making predictions. You're gonna I guess what we need to do is we need to kind of split our data into training and validation sets and do things like that. But this is basically what it does. And so in fact, Scikit-Learn, like, you can call and ask what are the coefficient, the slope, and if x had more than one predictor, you'd get kind of an array here, and then the intercept would be something else. But it's not, Scikit-Learn intention is probably not for you to even figure out what the actual coefficients and intercept are. Okay, I print them out here, but they actually come with this underscore, meaning like, yeah, you could get it, but a lot of times if there's an attribute that is followed with an intercept, it generally means like, I'm not quite sure what you're gonna do with this thing. Okay, and again, Scikit-Learn's philosophy is kind of like, we're gonna take a model. The model's almost intended to be like a black box where you just plug something in and it spits out a prediction. and we evaluate the entire, like our entire opinion about this model is based on how well it's making predictions. And so everything's kind of geared around, you know, the cross-validation and evaluating the model performance that way. Okay, so, you know, do we care what the coefficients and intercepts are? You know, our traditional stats background says yes, we do care, but Scikit-Learn has a different philosophy about how models work. Okay, so this is just the very intro of this. On Wednesday, I guess I'll go over the last year's midterm and try to answer and field your questions there, and then I guess in 8th week we'll talk more about Scikit-Learn and fitting their stuff there. Okay, we'll end here for today. We'll see you guys in a couple of days.